Hello everyone. In this video, I'm going to solve the LeetCode Problem 91, Decode Voice. So the problem says we are given a string of numbers, and with that string of numbers, we want to know how many ways we can decode it into a string of characters. And we are given a specific mapping here. So we have integer 1, 2, all the way to the 26. And each of these integers can map to a different character. So down here in the example, we can see a string like 12 can be decoded in two different ways. One way to decode it is just 1 maps to A, 2 maps to B. Well, the other is that we can take double-digit values. That means 12 can map to L. So there are two different ways that this string of numbers could be mapped to a string of characters. So we return 2 as the output. There are a few different edge cases we should think about first. For example, we could have a string like 06, right? So what exactly does this map to? Well, 0 is not even in the mapping list. So basically 0 itself does not map to any character, right? So if we ever get a string like 06 or a string starting with 0, that means it's invalid. We should return 0. It cannot be decoded in any way. Okay, let's try to figure out how to solve this problem. Suppose we have a string 226. So how many ways can we decode it? Well, at the very beginning, we have two choices. We could take just the first character 2, or we could take the first two characters 22. So let's go down this path where we take 2. It leaves us with the substring 26. Again, we have two choices. Take the next 2, or take the next two digits 26. By the way, what if we had something like 27 over here? Then this pass would be invalid because 27 does not map to any character, right? The valid range only goes up to 26. So back to our example. In this pass, there's only 6 left, so we can take 6. In this pass, there's also only 6 left, so we can take 6. So as we can see, each pass breaks a string into substrings. And the total number of ways to decode a string S is the sum of ways to decode the remaining string after taking a single character plus the sum of ways to decode the remaining string after taking a two-character pair if it is valid. Okay, let's jump in the code. At first, I need to create an inner function called helper. With a parameter substring. And at the beginning of this function, I need some edge cases. If the substring starts with 0, we can just return 0. It's invalid, right? So if the substring's length is 1, then we can return 1. Then define a variable named count to store the result. Count equals to helper itself. with the parameter substring except for the first character. And plus helper with parameter substrings except first two parameter. But remember, the second one has some condition, right? So only if the first two characters are greater than or equal to 10, first two characters greater than or equal to 10 and less than or equal to 26. Another edge cases is that what if this one is empty, right? It is possible. If it is empty, that means we have already found a valid path. So if length substring equal to, that means we have already found a valid string, right? Valid way. So we can just return 1, else we return the number of ways for the remaining string. Okay, after that we can just return count, and outside the function we can just call helper with s. Okay, we can write it's pretty slowly, right? Its time limit exceeded. Okay, how can we optimize this function? So I want to say we can use dynamic programming. What's the difference between dynamic programming and recursion? It's, in my opinion, it's simple. We just need to add a cache to our recursion function, and if substrings have already in cache, we return cache substring, and here I need add cache when we had a results. Okay, let's try again. Good. And we can submit. As we can see, it is pretty efficient. And that's it for this episode. And thanks for watching. I hope to see you soon.